This is our project setup for vibration monitoring and analysis using Arduino UNO Q. Uh, right now we are seeing the hardware on the screen. It has two boards. This is ADXL345 for vibration monitoring, and this is the Arduino UNO Q board. The ADXL345 measures the acceleration for the three axes X, Y, Z, and these readings are then passed on to the microcontroller on ADXL345. The microcontroller is interfaced with ADXL345 using I2C. So there are six connections between the two boards, two for the power supply from UNO to ADXL345, two for I2C communication for transferring data from ADXL345 to the microcontroller, and the ADXL345 has two control pins, one to select the I2C interface and other two for the chip select. Okay, so this is the overall hardware setup. Apart from the hardware setup, we have the UI here. The UI basically, whenever there is acceleration, there are some readings. There are some readings which are transferred from ADXL 345 to the Unoku board, and you can see it on the UI. So this is the general setup hardware wise. So now we will walk through the UI complete. Okay, and if you see on the UI, just a moment. Okay, so if you see on the UI, we have the accelerometer readings coming from the microcontroller side. These readings are then processed by the microprocessor uh, using the FFT libraries, and you can see the FFT spectrum. Other provisions on the UI are to change the axis, and based on the FFT spectrum, the LLM prompts are generated. So we'll move to the UI and see the 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 axis change portion and also the portion related to the LLM prompts. Okay, okay. So let's go to the UI. Okay, so this is the UI. So you can see that changes causes change in the reading, and you can change the axis. This axis selection is based on which axis is the principal axis for the vibration monitoring. Okay, this is the prompt which is generated based on the current reading of the FFT spectrum. Okay, you have an option to copy this prompt and send it to the any AI of your choice and get the response from that. So I'm copying it. Okay, and let's see how we get the response here based on the prompt. So this is the response from Copilot. Okay, so let's go back, and there is one more option uh, to analyze it with LLM. So if we do this analyzing with LLM, it will send this prompt to the onboard AI model. Right now we have installed 5 3.5 for generating the LLM response. So now we'll go back, have a look at the code also. So right now you are seeing the code window. So let's have a look at the code side. Okay, just give me a moment. We'll walk through the code. Okay. So the code arranged is such a way that sketch.io has the Arduino wire library and the router bridge. Basically, it takes the reading from ADXL 345. This is the slave ID of the ADXL 345. Wire library is used for I2C communication, and the XYZ readings are sent to the microprocessor. These are the two control pins which we discussed earlier. Okay. On the microprocessor side, this is the main Python code. It handles the Pi server. It calls the sensor and takes the reading from the sensor. We have a code for FFT selection, a rolling window for FFT calculations. This is the bridge registration for transfer between microcontroller and microprocessor, FFT generation code, and the LLM build for LLM prompt builder. This is the request response from the LLM, and we have the analysis from the phi model. Okay. On the UI part, you have the three major components here. If we see accelerometer to handle the accelerometer graph, FFT for FFT spectrum, and LLM prompts. Okay, these are the three major components. Style.css handle the styling part. App.js handles the dynamic behavior of the UI. So this is the code layout. So with this, we have seen all the components. The Basically the app part, the UI part, and the hardware part. Okay. Thank you. Bye.